Okay, hopefully this works. My YouTube or iPad is being a major pain in the tootie butt, and it's stopping me from recording. So that's fun. So we left off. We put all the x values into the calculator. And then when you go over, like if you're typing in values and you hit over, you can see that it's waiting for you to type in more values. But we're not going to type in more values. We're going to type in an equation that's going to calculate the y values for us so that we don't have to go through and cube 0.5 and cube 0.9 and cube 0.99 and cube 0.99999 and so on. So when we do that, when we want to type in an equation, we have to go up to the top and then hit enter, and you'll see the blinking cursor comes here. So let me show you one more time. If I'm typing in values and I hit over, it's going to just ask for numbers. But if I go up and then hit enter, the blinking cursor comes here. Now, I want the calculator to calculate the y value, which is the x value cubed. The x values are in my L1, so I'm going to tell it to do L1, which is shift 1. Do you see that right there? L1 cubed. So this is telling me the y value, which is going to be placed into L2, is going to be the x value cubed, and the x values are coming from L1. And then if I hit enter, it populates those. And we know that 5 cubed is 129, and we might know that 9 cubed is 729. So you can see that that's what's happening there. And if you have space on your paper, you can write these. I didn't leave enough space. 9703. 997. I don't want to keep you guys on to write all of these out. Well, this is just going to take another second. So these are the y values that are, what was this? I lost it. That's a 3. These are the y values that are corresponding to these x values that we picked to get really close, okay? And then all the way down, I want this 1, 1 to stay the same. That's the stationary point of tangency. It's not moving anywhere. It's stationary, right? So every time I make a new green line, this point is getting closer to the point of tangency, but the second ordered pair that I'm using to calculate the slope is going to stay the same, okay? Now I'm going to have it calculate the slope for me. I could go through and manually calculate the slope on every single one of these. I could go 1 minus 0.5 cubed over 1 minus 0.5. I could go 1 minus 0.729 over 1 minus 0.9. I could go 1 minus 0.9703 over 1 minus 0.99. That doesn't sound like fun though, okay? So I'm going to say, going up to the top again and hitting enter, I'm going to tell it to do a formula. It's going to be the y value here, which is always 1, minus the y value here, which is stored in L2. Note second 2 to get L2. Okay, so this y minus this y, this y minus this y, this y minus this y, all the way down. This is always 1, the y value. This is always what's in L2. Divided by the x value is always 1, minus these x values are all in L1, and now it's going to calculate all the slopes for me when I hit enter. So I definitely need to write these down from my table. So 1.75, 2.71, and so on. I'm not going to say these all out loud. And then I'm going to draw a line right here, and you'll see why in a second. Did I not go far enough? What happened? Oh, I didn't put in 2,8, darn it. Okay, I could calculate this. What is it going to be? 8 minus 1 is 7, 2 minus 1, so this is 7. Okay. Now, look at what's happening with the slopes. The x values are getting really close to 1 from either direction, from the left and from the right. That means our point on that secant line is getting really close to the tangent right there. And then we would be going like this and getting really, really close. That's a limit in itself. But you can also see that the slope is a limit. What's happening as my point gets closer to the value of the slope? And what's happening as my point gets closer to the value of the slope? The slope is approaching 3. This is why I said, like, if we would have left, I don't know, this one off, we might have not been convinced that that was getting really close to 3. I would actually like to see one more, but I think we're pretty convinced that the slope is approaching 3. So what this is telling us is all of these secant lines that are getting shorter and shorter, the second point is getting so close to this point of tangency, those secant line slopes are getting close to 3, and therefore we can say that the slope of the tangent line is equal to 3. So we're going to say the slope of the tangent line is equal to 3. We know it goes through the point 1, 1. So algebra 1 now, we're going to just use point slope form and do that. Okay, don't simplify that on the AP exam. Leaving it in point slope form is perfectly fine. But if you put it into slope intercept form and make a mistake, you lose the point. So don't bother simplifying it. All right. So what I want you to do is this exact same process for y equals x squared. I want you to draw me a nice picture at x equals 1. Your ordered pairs, your x values are going to be the same, right? But your y values, instead of being cubed, are going to be squared. Okay, so I want you to stop and go back and rewatch this video to go and figure out how to do the steps on the calculator, because like I said at the beginning, I really don't want you to memorize those steps. Okay, there's no point in doing that. And that is your only homework problem. All right, I will talk to you guys later.